Okay, so in this second video on sketching exponential functions, I'm going to go through first of all and talk through these transformations, and then we'll try and sort of sketch them out, and we'll check our answers using the calculator. So the first question, sketch y equals 10 to the power of x and y equals negative 10 to the power of x on the same set of axes. Well, we know that 10 to the power of x is just an exponential function where the base is more than 10, so the shape of it should be something like that. Negative 10 to the power of x, however, well, this has a negative out the front, and that negative is a reflection in the x-axis. And if you think about reflecting this graph in the x-axis, it's going to turn it upside down, so it's like that. So I'm going to draw both of these now. Remember that this graph normally has an asymptote along the x-axis. So I'll draw my x-axis as a dotted line. And I know that when x equals 0, 10 to the power of 0 should be 1. So then I can draw my exponential function, and it'll look something like that. I should really include one other point because I've only got 1 point on the graph at the moment. We should sort of show 2 usually. If you've had x and y intercepts, then that's nice. But obviously this one doesn't have an x-intercept, so we need one other point. So I'm just going to use when x equals 1. And when x equals 1, we get y equals 10. So I could put a point like up here somewhere. And if we extend the graph out far enough, we'll get the point 1 and 10. So it just shows that, yeah, we've got a little bit more information than just that one little bit. But then I need to draw the y equals negative 10 to the power of x. So again, I said that was a reflection in the x-axis. So instead of having a y-intercept of 1, it's going to have a y-intercept of negative 1. And when I draw it, it's going to go something like that. And it's going to have a point down here, which will be 1 and negative 10. So yeah, there we have it. The two graphs on the same set of axes. I'll bring that up on the calculator now. So bring up the graph. I've already typed all these equations in. So y equals 10 to the x, highlight it, drag it down. There it is. And y equals 10 to the negative x, highlight that, drag it down. Oops, that was 10 to the negative x, not negative 10 to the x. Let's try it again. There it is. So the one in green is the one that we want. Rightio. Let's have a look at the next equations. So sketch y equals 2 to the x and y, I should put y equals in front of that, 2 to the x plus 3 on the same set of axes. So we have a plus 3. This is a vertical translation of 3 units in the positive direction of the y-axis, or basically it moves the graph 3 units up. Okay. So when I sketch this one, the y equals 2 to the power of x will have the asymptote along the x-axis. By the way, yeah, sorry, I was a bit lazy in the last one as well. I didn't even label the asymptote. Should make sure I write y equals 0 there, because we always label an asymptote with its equation. So y equals 2 to the power of x. It's going to pass through 0, 1. And the base is more than 1, so I know it's going to be this positive sort of shape. So there it is there, y equals 2 to the x. And I I should put one more point, which would be when x equals 1, y equals 2. That should be sufficient. Now the other equation was 2 to the x plus 3. So everything about this graph has moved up 3 units. So the asymptote, which was originally at y equals 0, is now at y equals 3. There's 1, 2, 3 there. So I'm going to put the other asymptote here. And label that y equals 3. The point 0, 1 moves up 3 units, so it's now 0, 4. And the point 1, 2 moves up 3 units, so it's now 1, 5. And so we get a shape like that, which is y equals 2 to the x plus 3. So the entire graph moves up 3 units, and again we'll confirm this on the calculator. So there's y equals 2 to the x, and y equals 2 to the x plus 3. So yeah, one thing about this calculator is it doesn't show asymptotes. We need to sort of recognize them and see that, yeah, look, this graph here, it's clearly approaching a value of 3. It's not going to reach it, but yeah, again, the calculator doesn't tell you that. You need to sort of make that judgment call for yourself and be familiar with the types of graphs. Third one, sketch e to the x and 2e to the x on the same set of axes. So remember, e was just a number like pi, 2.718, and so that means the base is greater than 1. And this number 2 at the front here is a dilation by a factor of 2 from the x-axis. So what that means is that everything is twice as high as it was originally. So when I go to sketch this, draw my y-axis, draw my x-axis, which is an asymptote, label the asymptote, and then when x equals 0, y equals 1, base is greater than 1, so I know it's got this kind of shape here. So that's y equals, e to the x. Now when y equals 2e to the x, well, if I put an x value of 0 there, then 2 times e to the 0 is going to be 2. And it's still going to have the same asymptote, but it's going to be a little bit higher than the original one. Oh, that was a bit lumpy. So then we get that kind of shape, y equals 2e to the x. I should label another point on there as well. So when x equals 1, for example, then y would be equal to e to the power of 1, which should be about here somewhere, 2.7. So I've got the point 1 and e. And likewise, I should have the point here, which would be 1 and 2e. So anyway, that's how we can graph those ones. And again, I'm going to just confirm on the calculator. So get those equations, e to the x and 2e to the x. There we have them. Just so you're aware, to get the e on the calculator, it's this button right here. So that one there is e to the power of something. That's how you can write those equations in. Anyway, I will leave that right there and see you all in the next one.